It's the previous IBMT question from uniform circular motion. Let's have a look at the problem. A particle moves along a circle of radius 20 by pi. Let's write down what's the data that is given for you. That radius of that circular path is given for you as 20 by pi meter. With a constant tangential acceleration. Let us try to understand what's the meaning of this tangential acceleration. When a body is in a uniform circular motion, non-uniform circular motion, it will have two kinds of accelerations. One is called radial acceleration towards the center. One is tangential acceleration. So the resultant of that two will be somewhere in between. So tangential acceleration at is nothing but equal to r alpha. This is the basic formula that we have learned in units and dimensions. That's one point that we shall be first of all familiar. So if we have to calculate finally what is the tangential acceleration is, I need to find out r, of course given for you. I need to find out alpha, that is angular acceleration, so that I can solve the problem, right? So let's see how to go ahead. If the velocity of the particle is 80 meters at the end of second revolution, so what happens after second revolution? Let us try to understand that also. When it completes one revolution, come back, it covers an angle 2 pi. Again it goes and come back. So after two revolutions, angular displacement is 2 pi and 2 pi, 4 pi. For each revolution, it covers an angle of 2 pi. Taking these basic things into consideration, being the body is in circular motion, similar to equation of motion in say one-dimensional motion like linear velocity v square minus u square equal to 2as. In terms of angular velocity also, omega final square minus omega initial square equal to 2 into alpha into theta. Here linear velocity, here angular velocity, here acceleration, here angular acceleration, here displacement, here angular displacement. That's a comparative equation, right? Now, one thing that was not mentioned here is that it's initially not starting from the state of rest, but that has to be taken for granted. Assume that's given for you. Assuming that initial angular velocity is 0, what happens then? Omega final square minus 0 equal to 2 into alpha into theta. So alpha equal to omega final square by 2 into theta. So if I have to solve that problem further, I need to know what is this omega final square is. For solving that omega final square, we have a value, we have a equation like relation between linear and angular velocities, v equal to r omega. So I have a lot of basic formulas. You must be familiar with all these formulas. If not, please refer to the playlist of rotatory motion. I have derived all these formulas for you. You can just go through and see from where these formulas are coming, right? So omega equal to v by r. It is given that its v after two revolutions is 80 meter per second. So that data is given for you, 80. Radius is also given for you, 20 by pi. So this becomes 80 by 20 into pi, that is equal to 4 pi. So you got that omega. Once you got that omega, substitute that omega here. Omega above. What happens? Alpha is omega f square, that is 4 pi whole square by 2 into theta. How much angle it covers after two revolutions is 4 pi. So in the place of theta, you can write 4 pi. So 4 pi whole square is 16 pi square by 8 pi. So that's nothing but equal to 2 pi. You got the value of alpha, right? Once you know the alpha, you also know the radius. then you can get tangential acceleration. So that implies tangential acceleration of the non-uniform circular body AT is equal to R alpha. R value you have found as 20 by pi, given as alpha is I have got the value of alpha as 2 pi, right? So that's value is pi and pi can be cancelled. 20 times 2 is 40. It's being an acceleration as a unit of 40 for meter square. So that's the answer, meter per second square. That's the answer for the problem. That's how we have to solve the problem. So to remind you, we have used many formulas here. First of all, tangential acceleration is R alpha. You shall know that. Each revolution covers an angle of 2 pi. After 2 revolutions, angle covered is 4 pi. You shall know that. You also know an equation similar to v square minus e square equal to 2as can be written in angular motion also. And this is the relation between linear velocity and angular velocity, right? So as we need tangential acceleration R alpha, we need alpha, right? So first we have found alpha here, right? But to solve this alpha, we need omega. So first we found omega, substituted that omega here, found alpha, substituted that alpha here, and found tangential acceleration. That's how we had gone through the problem. So there are series of steps, and we shall think carefully while you are solving this problem. Then only you can understand the concept and utilize same or similar concepts further whenever it is needed. That's it. Thank you for watching.